All right, so picking up once again. So we had our two theorem, or we had our two criteria that didn't work, our AAA and our side-side angle. We're going to talk about what special situations side-side angle actually does work in compared to our other ones. So we call this situation hypotenuse leg. What is the hypotenuse of a triangle?
No, the measurement, that's the pi.
That's for a circle.
That is for circle. Pi.
The hypotenuse of a triangle, that's always going to be your longest side of your triangle. So our longest side of our triangle, that's called our hypotenuse. A leg of a triangle, the leg of a triangle is going to be any of the smaller sides. So both of those two smaller sides are considered legs. So a triangle has two legs and a hypotenuse. So we only need, if we have a hypotenuse and a leg and a right angle, specifically a right angle, then this is enough to prove two triangles will be congruent. So even though this is side-side angle, which we're not supposed to use, if it's side-side right angle, then that is allowed. We call that our hypotenuse leg. But we want to figure out, why does this work? Why does it only work for having a right angle? Or why is having a right angle enough information to always prove that these two will be congruent?
So both parts of the long.
Well, yeah, like a right angle, it can only be like 70 degrees.
Like you get
A right angle, right triangles look like the same.
What can we do with right triangles that we can't do with other triangles? What theorem can we use?
something about adding
A right angle theorem. Straight line.
If you had this triangle, can you find x?
Yeah.
How?
3 plus 4. Oh, so 3 times 4.
What do we use to solve for missing sides of right triangles?
90 minus 4, 90 minus 3. What are you saying? I thought I was right.
Cereal. Oh, midpoint? Wait, no.
Pythagorean theorem.
Pythagorean theorem. Anytime you're looking for a missing side of a right triangle, we can solve for it using Pythagorean theorem. So a squared plus b squared equals c squared. C squared, where c is always your longest side of your triangle. A and b are your two legs. So, let's say we have this situation. We have two right triangles. We know that their hypotenuse are the same. So let's say their hypotenuse are 16. Their side lengths are, actually we're going to say their hypotenuse is 13. For whatever reason. Their side length is 12. Could I solve for the missing side of both of those right triangles? Using my a squared plus b squared equals c squared, it would be a squared plus 12 squared equals 13 squared. It'd be that same situation for both of them, right? That same problem, because they both have that same hypotenuse, they both have that same leg. Would a turn out to be the same number then? No matter what, I'm going to get the same. It's the same problem, so I'm going to get the same answer, right? So whatever a is, it's going to be that third side. So no matter what, as long as I have two sides of a right triangle, and knowing it's a right triangle, as long as I have two sides that are congruent, I can always assume that third side is going to be the same, as long as my triangle is a right triangle. So hypotenuse leg only works if you have two sides and a right angle. But if you have that situation, it does work. Unlike typical side-side angle where you can't use it, you can only use it if you have a right angle and you have those two sides. But it does work all the time. Are we okay with this? So now we have 5 criteria. We have those 4 we talked about earlier, and we're also going to add hypotenuse leg. So we're going to practice this one, and we're going to see it as an example. So we have triangle EFG is congruent to triangle FGH. We're going to start off with an informal proof, so we're not going to worry about the two columns right now. Start off with what's given. So looking at that picture, what information is told to us just from the picture? So we have EFG and we have FGH. We have angle EFG is congruent to angle H, G, F. Because they're both 90-degree angles. They're both right angles, right? So E and I guess E and G matched up. I guess I would switch around. F, G, H. Correct. So I'm told both those angles are congruent. What else am I told?
I don't know how to say that.
So we have these little hash marks, which tell us those two sides are congruent. So EF is congruent to EF is congruent to HF. Not EF, I'm sorry. I'm all doing all over the place. FG, EG is congruent to HF. So that's what's told to us from the picture, what they labeled on the picture already before us. So sometimes you're given information written out, sometimes it's posted on the picture. Both of them are still given information. Now that we have these pieces of information, now we want to start looking for that extra information to get those three pairs. We have two pairs. We have a pair of angles and we have a pair of sides, but we need one more situation. Amanda, what did you notice already that you mentioned before? So we need parallel lines for both connections. So FG is congruent to GF by the reflexive property. They share that side length. Colton, let's put away your phone, please. Thank you. All right, so we have hypotenuse, we have a leg, and we have a right angle. So based off that information, we can say by hypotenuse leg, triangle EFG is congruent to triangle FG. Are we okay with this? So you use that new criteria, our angle side, but because it's a right angle, it's hypotenuse leg. So right angle side works. So once again, we're going to keep practicing with these triangle congruence proofs. We just want to be able to work through the situations, work through those two-column proofs, and sort of remember how to fill in those pieces and start figuring out some situations or figuring out some skills to be able to solve them. So with this one, once again, we're just starting off fresh. So we're just going to fill in the reasons. They already have the statements to fill in. We just need to figure out what the reasons are. So based off this picture, based off what was said, their first statement was angle B is congruent to angle D, and AB is congruent to ED. So why are they allowed to say that? It's given information. It's told to us in the statement, it's told to us in the picture. So angle B is congruent to angle D, and AB is congruent to ED. So we have two pieces of information told us straight away. So we have two pairs, which is great. We just need one more pair, and then we can prove that they're congruent. Colton. Your turn.
Vertical angles.
So we have vertical angles. So we can, or they have ACB is congruent to ECB by the vertical angles. So now we have we have one set of sides and two sets of angles. So they said that was enough information to say these two triangles are congruent. We just need to figure out what criteria they use.
Angle side angle.
So this one's going to be angle, side. The reason because that side length does not fall in between those two angles. It's outside the two angles. If it were this side, then they would fall in between. But because it's not in between, we need to write it so. I'll take a swap. Does that explain why it's talking? Okay, angle to angle side, we have two congruent triangles, and we finish this problem. Are we okay with this? So same situation, we have part of the information filled in, but we want to fill in those blanks. So we have this sort of parallelogram going on for us. What should be our first statement? Always.
The given.
Given information. So we were told given information of EF is parallel to HG and HE is parallel to FG. So our only piece of given information was that we have a lot of parallel lines. That was the first thing they wrote down. The next thing they said, their next statement was HF is congruent to FH. So they said HF is congruent to FH. Why are they allowed to say that? It's a reflection property. Good. So by the reflexive property, they both share that side. So it's automatically going to be congruent. Now they sort of made two statements in one. They said EF congruent to GHF, and they said EHF is congruent to HFG.
How do you notice what the angles are?
So
Oh, yeah.
EFH is this angle, and then GHF. So if you sort of like, I like to bring my finger along.
Is it the middle that's always the angle?
Yes. So once again, that middle letter is always the vertex of your angle. So whatever letter shows up is where the vertex of your angle is going to be. So this is angle F, angle H. But because we have multiple angles coming off from those vertex, that's why we like to put the three letters to distinguish which ones we're actually talking about. So these are alternate interior angles. Good. The way we know that is because we have all of these parallel lines. So these parallel lines, and we have our transversal down the middle. And so that gives us two sets of alternate interior angles. But because they're both formed by alternate interior angles, they just formed it into one statement, which works. So we have two pairs of angles, and we have one pair of sides. So what criteria can we use to prove that these two are congruent?
Is this one angle side angle?
This one is angle side angle. And because that side length falls in between your green and your blue angles, it is angle side. Good. And that proves we have congruent triangles. All right, on this last one, we're going to try to step it up just a little bit. We have no information filled in for us. We need to fill in all of those statements and all of those reasons. Also, they didn't write down any given information. We have to figure out what the given information is seen in the picture. So looking at that picture, what is shown to us directly that's given information?
Give a reflexive line property.
So even before the reflexive property,
ABC, ABC are congruent.
we have all of these congruent lines. So they told us BB is congruent to CB, which is congruent to AC, which is congruent to BA. So all of those lines are equal lengths, so they're all congruent. We can see that from the picture, so that's technically given information. So if it's labeled on the picture, it's given information, but if you sort of have to discern and figure out what property allows it to happen, then it's no longer. All of these ones were labeled for us, so we didn't have to figure any of that out ourselves.
We have to.
On the quiz, I'll most likely give you a statement that say you're given information. I probably won't drop that off. But just in case that were to happen, I want to keep you prepared. I don't know what they're going to put on your state test. So we have two sets of congruent sides to start off with. On each triangle, so good. We need to find one more thing. Then we have BC is congruent to CB by the reflective property. Good. What can we fill in for that third statement? So our reason can be side, 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 because we have three congruent sides.
Would this statement be D, B, C, A, B, C?
So triangle, you would say DBC is congruent to triangle ABC. Good.
So it's still side, 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 even though there's not like 1, 2, 3.
Yeah. So we can make a pair with, say, AB and DB. We can make a pair with AC and DC, or you could do it either way. They're all the same length, so it doesn't really matter how you make the pairs, but knowing that you have those two pairs. And then you have, and then robust property.
And then you should know that it is side, 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 because there's no angles.
Yeah. Yeah. You have, if you have no angles, but you have three side lengths, it's automatically side to side. There shouldn't be any worry about that one. So good.
So chill.
All right, we're going to do one final problem. We don't have to do it as a two-column proof, but we can if we want. It's up to you. But it's sort of a challenge question. We want to prove that ABC, the triangle ABC, is congruent to triangle ADC based off of this image. So, thinking about what's given to us to start off with, what's shown to us in that picture from the very start that we didn't have to do anything to solve for.
That angle, angle AC or BA.
So BAC.
How do you know which one?
So
Put back and down.
BAC.
Oh, that's the whole thing. Okay.
That's one angle. That's going to be congruent to BAC.
Back and down.
So we're told those two angles are congruent based off the picture. Angle symbol. Okay, so we have a set of congruent angles. What else do we know? By the reflective property, they share that middle side. Fine. Okay, good. So we have a set of angles and a set of sides. Do we have anything else? So we don't know that.
They make triangles.
They can make triangles. So A, that is the center of my circle. What do we call it when we go from the center to the outside? It's a radius. So a radius is any center to the outside. Makes a special, or what makes a circle special is it's any point on the outside of the circle is the same distance from its radius, or same distance from its center. It's always that same radius. So how can we use that information to help us?
the A, like D, C, and B all have like that same like outside like distance, they're all like the same length from like A.
So AD, AC, and AB are all radiuses of our circle, so they're all going to have that same length. So you could essentially say that AD is congruent to AC, which is congruent to AB. Because they're all those radiuses. Can we prove that they're congruent now?
Yes,
Why?
side equals side.
So by side angle side, we have congruent triangles. So we have our sides that match, our angles that match, and our third sides. So good. And that's where we'll